Hello everyone. Today I will be present the mechanics of the kick drum pedal. This is the kick drum pedal project prepared by group number 3. And let's have a look at the working principle. The purpose of this equipment is that changes the downward push of your foot into a spinning motion to hit the drum by multiplying your force that you applied. And then there is components and their purposes. The first one is footboard, is the plate on which the drummer's foot rests and is the equipment that provides the transition of the player's movement into the energy. And there are two types of footboards, which are short boards, have a separate heel piece and give a classical feel. And there is longboards, are one single long piece, and they are more sensitive and I guess much better for fast food techniques. And there is the driver, the second one is, which connects the footboard to the top of the mechanism. And there are three primary drive types. First one is chain drive, are stable but needed to cleaning. Then strap drives use a belt, so they are very quiet and smooth. And there are direct drives, use solid metal, for instance, energy, perfect for extreme speed. And the third one is the cam, which turns the pulling motion into a rotation. And there are two primary of them. A round cam gives a smooth regular feel, and the other hand, offset cam is shaped differently. It accelerates the beater and the very end of the stroke for a much harder hit. And the fourth one is the beater, which strikes the drum. Its material changes the sound completely. For example, felt sounds warm and punchy, and plastic sounds sharp and clicky, and wood is very loud and bright. Next. And the fifth one, finally, is spring mechanism. Pulls the pedal back up. A tight spring bounces back quickly for a fast rock or metal music. A loose spring feels lighter and smoother, which is perfect for the genre of jazz. Now Mehmet Songur is going to explain the physics behind the working principle of this pedal.
Hey everyone, I am Mehmet. I'm gonna introduce you general working principle by steps. I'm gonna start with first step as the initiation part, footboard. When the drummer applies the pressure to the footboard, the downward linear movement is transmitted through a pivot point or hinge. And in our calculation, we're gonna ignore the weight of the footboard. This is simplify our calculations. In the second part, I'm going to introduce you transmission part, driver. The movement is transferred via this driver to cam. I'm going to show you what is purpose of the cam in the next slides, and we're going to assume the driver is massless so that our tensions is going to be same. In the third part, conversion part, cam part, the cam SMB converts to the linear movement into rotational motion for the beater so that we can calculate our kinetic energy. I'm going to show you in next slides, and there is our torque formula. There is a torque of the cam minus torque of the spring, and we're gonna ignore the torque of the friction and torque of the weight of the beater. In the fourth part, there is a calculation for the impact of the beater. The rotation of the shaft propels the beater forwards, causing it to strike the bass drum head. By using torque and energy, we can calculate impact force. And we're going to put here one efficiency model for removing effects of the weight of the beater, spring, friction, what you assume what is there. And in the next slide, I'm going to show you main purpose of the spring. Immediately after the impact, your stroke, the potential energy stored in the spring SMB takes over, and spring repeats to pull the beater and footboard back to their original resting position, resetting the mechanism for the next stroke. And in our calculations, for easier calculation, we're gonna ignore the torque of the spring. And in calculation of impact force, we're gonna use impact momentum theorem. We're gonna use equivalent mass contact of time, and we're gonna assume velocity of final velocity gonna be 0. There is no bouncing our assumptions. And here one example, there's our assumptions and our values. By using values, you can calculate your impact force 246 newtons in these values. But if you change your contact time to 3 milliseconds, your impact force is going to be 3 times less. You should know that before your calculation and assumptions. Contact time very highly affect on your calculations. Thanks for listening.
Hi everyone, I'm Tuna. Today I'm going to talk about kick drum pedal and the materials which are used in pedal. Kick drum pedal is one of the hardest working mechanical parts in the music world. It transfers the power from drummer's foot to drum, and the choice of materials must provide a balance between some factors such as durability, strength, and lightness. Let's start. These are some requirements at material choice: strength, lightness, durability, and the cost. And this is the kick drum pedal, as you can see. And the first part that I introduced the materials of is the footboard. The footboard is made of cast aluminum because aluminum is beneficial for lightness and speed. And it also provides the pedal with high acceleration by minimizing the inertia, and offers excellent resistance against corrosion. And the footboard part is here. Another part is the frame. The frame is made of steel, but sometimes it can be made of heavier aluminum alloys. And the properties like strength and durability are crucial for that part. The third part is the base plate. The base plate is made of heavy carbon steel or thick solid aluminum plates. The required properties are anchoring and shock absorption. And at that part we need mass, because heavier steel base plate provides a low center of gravity and preventing the pedal from sliding over. And the base plate is here. And the last part is the heel plate. The heel plate is made of cast iron, steel or heavy duty aluminum blocks. The priorities are durability and pivot stability. And because that part doesn't swing into the air, so lightness is less critical and the main focus is on durability. And the heel plate is here.
Hello, my name is Batu Ada and I'm with the third group on the project on the kick drum pedals. And I will be presenting the rest of the materials section. I will mostly be focusing on the materials used on some of the moving parts. They are usually made out of steel and aluminum, but other materials are used as well. We will also focus on the beater head towards the end of the section because many different types of materials are used just there. So let's get started. Chain drives are usually made out of steel. This is because they have good enough strength and resistance to fatigue, which is good enough for this purpose. Belt or strap drives are usually made out of nylon or Kevlar. Nylon is sometimes preferred because it's quite light and it's quite cheap. Kevlar is a popular choice for belt drive pedals because of its very high tensile strength and the fact that it is very lightweight, which makes it great for this application. Springs are made out of stainless steel or a type of high carbon steel called music wire steel. This type of steel is preferred because of its great tensile strength and exceptionally high resistance to fatigue. And resistance to fatigue is important here because springs will be loaded and unloaded millions of times throughout their lifetime, so they need resilience to that. Bushings are usually found in sections in between parts where there is a lot of friction going on. These provide some resistance to that friction. They are usually made out of bronze or sometimes brass because they need to have good wear resistance since friction are removed. Titanium is sometimes found in the most professional types of pedals. Even then, it's still pretty rare. It's comparable in terms of stiffness to steel, and the part where it shines is the fact that it's lighter than steel, but still the advantage is small and the cost of titanium is very high, so it's rarely used. The beater heads can be made out of many different types of materials, and the material selection is very important because this will decide the sound that the drum will make in the end. Some of these materials are felt, plastic, wood, and rubber. The most common and traditional beater material is the felt. Felt is soft and tends to deform, making the sound warm and well balanced. Plastics are usually much harder compared to felt, which makes their sound sharp, hard, and clicky. The plastics involved are usually acetal or nylon. Wood is even stronger compared to plastic, which makes their sound more like a thwack than a click, unlike plastics. Rubber is softer than plastic but harder than felt, which makes them a good middle ground in between the two, and that's the end of the materials section. The market research section will be continued by Mark.
Hello everyone, this is Mark. I'm going to introduce you to the market research part of the kick drum pedal project. We collected data from biggest music stores in Turkey, Zuhal Müzik, Dure Müzik, and mydukan.com. We calculated things like the means, medians, and ranges, and analyzed two data sets, which are the general market, that includes all kinds of pedals, and the single kick drum pedal market, which includes only single kick drum pedals. We must say, however, that the data for the general market is skewed towards higher prices due to the abundance of twin kick drum pedals. They cost more because of their mechanical complexities, and therefore they are costing more. This is the results for the general market assessment. You can see from the table that the values of the geometric mean and the median are approximately equal everywhere, which suggests that the prices of kick drum pedals follow a log normal distribution. Most of the pedals are 5 to 20,000 liras range, with a few high expensive outliers that skew the entire statistics. This behavior also reflects multiplicative growth in price rather than linear, which means that manufacturers, when trying to improve or introduce improvements in their products, make the final price, market price increase proportionally by a factor and not by a fixed amount. Now, if we remove the double drum pedals, we get a much more accurate assessment of the drum pedal market in Turkey. We can see that from the table all values decreased, but the geometric mean and median are still approximately equal, meaning that the market structure is relatively the same. We also did a product offerings analysis and revealed some of the market trends. For example, mydukan.com has the lowest median and provides mostly budget to intermediate level equipment from original equipment manufacturers and more recognized brands like Mapex, Tama, and DW. Zuhal Müzik offers the most extensive selection of kick drum pedals by far, most of which are dominated by Tama or Pearl, which are brands well known for their quality and history. Dure Müzik, on the other hand, is focused towards more high-end spectrum of drum pedals, providing flagship instruments of Yamaha, Sonor, and DW with exceptional build quality and features. On the moment of preparation of the project, the most expensive pedals are from Pearl Demon Drive XR series, the P3500D, and the double pedal variant 3502D. Both are the flagship models of Pearl, costing 44 and 99,000 liras respectively. The Demon Drive XR series represent the most advanced and the fastest pedals on the market that include specially designed machined aluminum construction, direct drive linkage and ninja bearings, various adjustability options, and it was developed together with professional drummer George Collias. There are several factors that highly affect the manufacturing costs and the price of the pedal. One of them is material choice, is the full aluminum construction. Next is some engineering solutions like optimized direct drive linkage, beater and footboard design. There are also vast adjustability options and professional development and research, and of course the long-standing reputation of Pearl in professional drum hardware. Now Ömer Bayram is going to introduce you to the CAD drawing of the kick drum pedal.
And hello, I'm Ömer. In this part, I'm going to be presenting the 3D CAD drawing of our model. Let's explain the master sketch first. Master sketch is used for defining pivot points, angle calculations, and 2D kinematics of the layout. For instance, this is our master sketch. Each line represents a different part. For instance, this 298mm part is our pedal, the 70mm is the link, and so on. Also, some points represent hinges and pivot points, like this one. Our methodology was to construct the model from bottom up. It means sketch the parts to the assembly in exact. It's like working on a feature tree on SolidWorks. Overall design and sub-assemblies. This is our overall design. As you can see, it has 3 sub-assemblies: the base, towers, and the motion system. The base consists of lower plate and its rubber padding, towers utilized for the placement of the main shaft, and the motion system is a system that transfers the force to the beater. The base is made out of 5mm thick aluminum sheet and constructed using sheet metal. Below the base is a rubber padding, ensuring the base not to slip, as you can see this dark color. The plate has been bent in a way that it forms the outer part of the pedal hinge. This is the place, to be exact. We bent the edge of the sheet so that it can form a hole for the main screw of the hinge. The tower consists of multiple different parts, namely aluminum tubes, CNC machined blocks, bearings, a spring, and a shaft. The sub-assembly's main duty is to house the central shaft in its desired place for motion system to operate. This is the overall shape of the sub-assembly. Parts of the tower, to better visualize it: the spring link, the 2 CNC machined parts, and this aluminum tubing with 2 holes. Also, this CNC machined parts has chamfers and radiuses. The motion system accommodates the beater clamp, link clamp, and the pedal. Each element has been bolted with each other or fastened to the center shaft using a set screw. As you can see, when the force applied like this on the pedal pulls the link and the clamps back so that the beater can move forward to kick the drum. Parts of the motion system, to better visualize as well: the beater, the link, and the clamps. The clamps has these holes for the set screws to be fastened on the central shaft. Also, this is the pedal, like the base. The edges are curved so that it can form a hole to be the part of the hinge. Lastly, the kick drum during its operation. As you can see, when the force is applied to the pedal pulls the system back so that the beater can move forwards. Thank you for joining and listening us.